Hey chemistry students, this is Mrs. Miller again, and today we're going to be working with calculating pH and pOH problems. In our previous video, we learned how to calculate pH and we used two equations for that. Today when we talk about calculating pOH, we are going to also be including two more equations. The first thing that I want to talk about with you guys is something called the self-ionization of water. Water is really unique when it comes to being an acid or being a base. Most things when we think about them in nature are either an acid or a base. Water is unique because it can act as an acid or a base depending on what it's mixed with. So what can happen is the molecule of water can either choose to receive or to donate an electron, and when that happens, we're going to notice that it's going to react differently in certain solutions. So the two ions have the same concentrations when looking at pure water. And the concentrations that I'm talking about are the hydrogen or hydronium ion and the hydroxide ion. So we know that when we talk about this, the hydronium or hydrogen is meant for the acid part, and then the hydroxide is meant for the base part. So when we're talking about pure water or distilled water, we assume that the concentrations for both of them, the hydrogen and the hydroxide, are both going to be equal, and the value that we put on that is 1.00 times 10 to the negative 7th molar. We know that acids like to release the hydrogen or hydronium ion, and bases like to release the hydroxide ion or OH minus. What we do is we have this self-ionization constant, or Kw, constant for water, and the way that we do that is we're going to take the concentrations of hydrogen ion or hydronium ion and hydroxide ion. We know that they are both 1.00 times 10 to the negative 7th, and we're assuming that it's neutral. So when we take those two and we multiply them, we get our constant, and that constant value is going to be 1.00 times 10 to the negative 14th. So that's a value that you guys are going to want to keep track of. The product of these two ion concentrations is always constant. So that means if one increases, the other has to decrease, and we know that that is called an indirect, or another term is going to be inverse relationship. So as one goes up, the other has to come down. So if you know one of the ion concentrations, you can calculate the other because we know what Kw is. So again, the H plus talks about the acidity, the OH minus talks about the basicity or alkalinity, or how basic it is. In the previous video that I made for you guys, we talked about different things with pH. We talked about how we could calculate pH when we only know the hydrogen ion concentration. So pH is equal to the negative log of that. We also learned that if we have the pH, we can still calculate out the hydronium ion or the hydrogen ion concentration by taking 10 to the negative pH. So a new one for us is if we know the pH, we can also tell what the pOH is, because when we take them together, they're related to one another. So the pH plus the pOH is equal to 14. If you think about the pH scale, remember that runs, so pH scale, it runs from 0 to 14. So it makes sense that whatever the pH is, plus the pOH, the total has to be 14. So we're going to be using that in some of our calculations today. What you guys are probably going to notice is that these questions are going to take us a little bit longer to calculate because there's quite a few steps that we need to involve. So this would be for a question where we are calculating the pH and the pOH using the hydroxide concentration. You could also do this if you knew the H plus or hydronium ion concentration, but for this example we have the OH. So it says an NaOH solution has a concentration of hydroxide of 2.4 times 10 to the negative 4th, and it should also say molar on there. Find the pH and the pOH of these solutions. So first and foremost, we need to be able to figure out what equations we have to use. So we learned of two new ones today. The first one we learned was Kw is equal to OH minus multiplied by H plus. And we know that Kw is equal to 1.00 times 10 to the negative 14. Okay? So what we have here is, if I look, we are given the OH, so we're given this value. We also have this value right here, so we can just rearrange and then we can calculate what we're looking for. Okay, once we have this value, we can also go through and we can calculate pH. So let's start by writing out what we would want to. Okay, so we know that we have Kw and we have OH. So I'm going to start by writing this out as 1.00 times 10 to the negative 14th is equal to our concentration of OH minus. So we have 2.4 times 10 to the negative 4th molar multiplied by H plus. So if I just want H plus by itself, I'm going to divide both sides by 2.4 times 10 to the 4th. So this side cancels out, and over here we are left with 1.00 times 10 to the negative 14th divided by 2.4 times 10 to the negative 4th, and that's going to be equal to H plus. When you go through and you properly put this in your calculator, what you're going to end up with is H plus is equal to 4.2 times 10 to the negative 11th molar. Okay, so that's the first part. The reason why I calculated out H plus first is because I know that if I have H plus, I can calculate out pH. So how do I do that? Well, that, of course, I'm going to do this in a new color, is the negative log of our hydrogen ion concentration is equal to pH. Okay, so that's one thing that we need to figure out. So if I plug this in, the negative log of H plus, oops, I actually want to put that in here, is 4.2 times 10 to the negative 11th is equal to pH. And when I put that in, pH is equal to 10.4. So that is the first part of my answer. As you can see, that took a little bit of math. First, you had to plug it into Kw so that you're able to get the H plus concentration. And once you have that, you put it into the pH equation. The last part of this, again, I'll use a different color, is we want to calculate out pOH. And if you remember, if we take pH plus pOH, that is always equal to 14. So now I know that 10.4 plus pOH is equal to 14. So if I subtract 10.4 from both sides, I end up with pOH, and pOH is equal to 3.6. Okay, so you guys can see that takes a lot longer to calculate, but that's how you're going to go through. If you are given the concentration here, you have to put it into Kw first and then go to pH and then pOH. Just like in the last video, I want to show you guys how I did this in my calculator. So the first thing that I did was the Kw equation. And that is right up here. So the first thing I did was I put in Kw. So that was 1.0 times 10 to the negative 14th. So you guys should be able to see how I did that. Again, I used that little caret button. And then I did divided by whatever my value was. In this case, it was 2.4 times 10 to the negative 4th. So when I plug that in, I, of course, use my parentheses so that the 2.4 times 10 to the negative 4th all stayed together. When I plug that in my calculator, I got 4.1666, whatever, times 10 to the negative 11th. I rounded that up to 4.2 times 10 to the negative 11th, which is my H3O+. Then what I did is I did the negative log. So I did my negative log of whatever my previous answer was. That's how I got my 10.4. And then my last one was I took 14 minus 10.4 to get my pOH. So again, your calculator might look different, but those are the values and the buttons that I used on my calculator. Here's the last type of problem that you guys are going to encounter on your worksheets. This would be calculating pH and pOH practice problems. And this one is actually coming directly from your worksheet. So this is number 4 on those practice problems. So this one says find the hydrogen ion concentration and the hydroxide ion concentration in a healthy human blood with a pH of 7.4. So this one I need to use some different equations than I did previously. Previously, we were able to use the negative log, but this time I am starting off with pH. What I can do with pH is I can solve for the hydronium ion concentration. So I can go hydrogen ion concentration is equal to 10 to the negative pH. So we learned that one in the previous video that I made for you guys. So now if I go ahead and I'm going to plug this value in, I know that H plus is equal to 10 to the minus, and now it's going to be 7.4. And when I go ahead and I calculate that out, my H plus ends up being, 3.98 times 10 to the negative 8th. I'm going to round it because I only want to the 10th place. So I'm going to round that up to 4.0 times 10 to the 8th molar. So this is just rounded. Okay, so that would be my first answer because I was looking for H plus. Now what I'm going to do is I need the second part of this. I need to figure out OH. So if you remember, KW is equal to OH minus times H plus. And we also know that KW is equal to 1.00 times 10 to the negative 14th. So now I have KW from my previous answer right here. I also have H plus. So now I can solve for OH minus. So I'm going to plug these values in. 1.00 times 10 to the negative 14th is equal to OH minus times 4.0 times 10 to the negative 8th molar. So both sides are going to be dividing by 4 times 10 to the negative 8th. This side cancels, and what we end up with is OH is equal to 2.5 times 10 to the negative 7th molar. So on the next slide, I'll show you guys how I plug that into my calculator as well. All right, so here's a picture with my calculator. So what I'm looking at here is first and foremost, as I talked about before, we wanted to figure out what the H plus was, and we had a pH. So what we had to do was 10 to the minus pH. So what I did again was I needed to get that 10 to the button. So what I did is the first thing that I have to do on my calculator is I have to go second button because that'll unlock this 10. Next, I pressed the log button because that gives me 10 to the. And then I just put in minus and then 7.4 and pressed enter. As you guys can see, I ended up with 3.981 blah, blah, blah times 10 to the negative 8th. So I just rounded that to 4.0 times 10 to the negative 8th molar, and that was my H plus. The next part was I used that KW equation, which is OH minus times H plus. So this value right here, that is KW. We know that one is a constant value. And then I just divided by my H plus value, and I ended up with this, 2.5 times 10 to the negative 7th. E, remember, means times 10 to the negative. So you could give me answers as 4.0 times 10 to the negative 8th molar, or if your calculator spits it out as 0.00 with all these zeros and then the 4 molar, that's fine. With OH minus, you could have this value with all of your decimal places, or you could also have 2.5 times 10 to the negative 7th molar. So either of those are fine. If you guys have any questions, let us know. Otherwise, have a great day.